Hey guys, welcome back to the shop. My name's Adam. So we're getting ready to start on my next project here, and so I've got a set of truck spindles, and you've already seen me do a little press work on them because I've already showed you that. So what we got here is a set of spindles, and customer he came up this past weekend, and he was actually referred to me word of mouth, which was really cool. And so he had a spindle, and he asked me could I do some repair work on, and so he brought him in here and we took a look at him, and he showed me he's got one bad and one is a sample. So he's got one of the shafts out of the spindle is really bad. You can see it's eat up on the small bearing journal, and the threads, they're just completely wiped out. So it looks like he had a failure on this, and probably drove it a little while and it just eat it up and just tore it all up. So he brought it in and asked me, is there something that you can do with this and save this spindle? I told him, I said, well, I'm pretty sure that I can fix you up and do something to get you going again. And so when I first started looking at him, there was still a lot of grease on it, and I couldn't tell right off that this was pressed together. It kind of looked like one unit, you know, but I was looking at it and trying to figure it out. But what he had asked me if I could do originally was weld this up and machine it, which I could do that. And I was looking at this housing, you know, the spindle housing here, and to try and determine if I could swing it in the Monarch, which I could if I wanted to. There is a center on the back of the shaft right there, so you can swing this between centers. But I kept thinking about it, kept playing with it, and it started running through my mind that, you know, this is an important part to somebody's vehicle, and there's a lot riding on this. You know, you've got the full weight of the front of the vehicle riding on this right here. This material that the factory uses, I don't know what this material is. Now, I did put a file on it. I was rubbing a little bit of file, and a file will cut it, and I can tell that it's tough. It's a good grade of steel. I don't know if they machined it and heat treated it and ground it and then pressed it in. I really don't know. But I'm afraid to weld this thing, especially the small end down here. I'm afraid to weld all this up and machine it and then risk weakening this thing and it liable to break off there. So that's when I started playing around with it and realizing, well, that thing comes apart. So I put it in the pressed on it, finally got it to move, and, you know, so I pressed it out. So bam, now we got us an easy job to do. We can just make a new shaft and put it in there. All right, so that kind of raised a couple more questions here, and this is something that I want to discuss with you guys. So you've got different material choices that you could pick to build this thing out of, this spindle shaft. So you got stress proof, like 1144 stress proof. You've got other grades of stress proof also. And you've got the good old 4140. I've used that many times to build a lot of shafts. And then you've also got ETD 150, which is a modified version of 4140. So I started looking at the numbers, tensile strength and yield strengths of the different materials. I was also checking out 8620. It's a nice material to use too. It's a good, strong grade of material. So I started looking at the numbers of the material, and I know that I wanted something really strong to go in this. So I picked out ETD 150, and this is the piece that I bought here. I bought this from McMaster Car, and I believe it was $72 for a 1 foot piece, 2-inch diameter. The bottom of the spindle shaft here is just under 2 inches. It measures around 1.920, so I've got just enough there to use a 2-inch to machine it out of. McMaster Car is actually a good place to buy from, especially for the small shop, you hobby guys. They've got a lot of different material available from them, and in small pieces. You can get 1 foot, 3 foot, 6 foot, all kind of different grades, and usually you can order from them. They have it in stock. You get it the next day or two. I know whenever I order from MasterCard, I get it the very next day. They got a warehouse in Atlanta. So I've got a book that I like to look in. It's got a lot of good info, but I want to go ahead and discuss a couple numbers with the material here. So I've got my, this is my Toll Metals book, and this is something that we've used a lot. We used to order a lot from Toll Metals. Also used a lot, used Alro Metals a lot, Sable Steel. We had accounts with a lot of different people, you know, because we were a full-time machine shop. So this is a nice book to have because it gives you lots of information. So I've got it marked with my scale there, and so if you look at McMaster-Carr, or even on the website, I guess, it'll give you the numbers that you're looking for as far as the strength of them. And we'll go ahead and we'll discuss a little bit on stress proof. And I believe on McMaster it's listed as 1144, but there is a few grades of stress proof. So let's just see what it says about stress proof. Free machining and high strength are the primary qualities of stress proof. This carbon steel bar has been severely cold worked to the strength level of heat treated alloys and then stress relieved. Stress proof chemical analysis compares to a modified 1144 and is used for parts heat treated from Rockwell 23 to 30. All right, on your mechanical properties, your tensile strength is around 132,000 psi. Your yield strength is 100,000 psi. All right, so let's just say that's for stress proof there. So those are good numbers, and stress proof is actually a very nice piece of material to machine. It's as I said, it's free machining. It basically it cuts like butter, man. You can use high-speed tool bits all day long on that stuff, and I use it a lot. All right, this old Toll book doesn't have 4140, so I don't have numbers to talk about there, but they're very similar to a stress proof. All right, so ETD 150, which is what I got, we got some numbers right here. It says that this alloy steel bar is suitable for applications requiring extremely high strength and good machinability, such as parts you are now heat treating from Rockwell 32 to 38. ETD 150 analysis compares to a modified 4140 alloy. By an elevated temperature drawing process, the following properties are reached. So it gives you your chemistry and mechanical property information right here. The tensile strength is 150,000 psi minimum. Yield strength is 130,000 psi minimum. So I like the numbers there. I like strength in numbers, and I got a lot riding on this job, so I want to make sure that I've got a good strong piece of material in this, and I feel confident that this will work good for me. It also says ETD 150 contains additives for improved machinability, and I'm not going to try to pronounce some of these funky names down in here, but anyway, this is I got a lot of these old books, and they're nice to have because they give you a lot of information. Like I said, I don't have any numbers on 4140, but they're 4140 would have worked good too. I'm sure it would have been, any of them would have worked fine, but I liked that the tensile strength numbers were higher with ETD 150, so that's what I went with. So we're going to go ahead and get started on this. What I decided to do was, as far as where we're going to machine this, I'm going to go ahead and use the Monarch lathe. The Monarch is a little smoother and quieter machine than the Victor, and I know you guys enjoy seeing that machine run, so I'm going to use the Monarch. I've never shown any threading on the Monarch on my videos before, so we'll do some threading on there because it's got a very nice feature to the cross slide that the other lathes don't have. So that's what we're going to use. So, but quickly, I'm gonna set this up in the Victor and face the end and put me a center in it, and then I'm going to chuck it up in the Monarch because this will not go through the spindle. and I like to chuck it up close when I do facing and center drilling. So I'm going to go ahead and get this set up and get it going, and I'll show you how it goes along the way, okay? Alright, first shoulder length is going to be 15/16. I'm going to step off and set my 0. Leave it about 5 thousandths shy so you can face that shoulder. Now that's the on the spindle. That's the threads and the undercut in front of it there. I'll come back and finish that later. All right, so I got my 0. Touch it there. I'm going to start with 100 just to see how it's doing. Alright, not bad. There's 200. That depth of a cut with a 432 insert, it would probably make a better chip than that. Speed it up a little. Another thing I want to point out real quick. The reason why I left this this full length bar is for 2 reasons. One, after I machine it, I can set it in the saw, I can cut it off and then face the back side. The other good reason of leaving something long like this is that if you screw up or make a mistake on this end while you're cutting it, you've got enough material there that I could cut this off depending on where it's messed up, and you can start over again. You don't have the whole material scrapped. I'm not going to turn it all the way to finished size here. I'm going to bring it down real close. I'm going to take another 100. And you can see that stuff. It's pretty tough material, but it machines nicely though. Okay, so we got about 40 to 45 thousandths come off of that right there. I believe I'm gonna leave that where it is. This thing's gonna get pretty hot. I'm gonna do all the machine work and I'll come back and finish it. Alright, the next dimension is actually going to go all the way down to the end, past the large bearing journal. And what I'll do is it's 2 3/4. And I'm going to set it with my hook scale here, and you've got a little bit of play with. Alright, I'm looking down on top of that insert, and it looks like the tip right on the edge of that line. All right, so we're going to set our 0 there. There's my witness line. Go ahead and throw a mic on this real quick. A quick measurement showing around 1.780. It's really, it hasn't really gotten too hot. I haven't done a whole lot of cutting on it, but what I want to do is turn the rough off of it. All right, I'm going to take 90 thousandths on the second pass here. That should put me right about 1.8. Yep, 1.801. So it is pretty warm. There's not a lot to come off that end that's pressed in with the inside the spindle itself. So we may just leave this alone for now. I'm gonna go ahead and get this finished here, and then we'll come back and turn this to the size right here. All right, I got her cooled down good, and what I'm going to go ahead and do is I'll go ahead and finish this journal. The bearing journal is actually only from like here down, and all this is going to be angled down to that shoulder, and then I'll finish this bearing journal and then finish that diameter there. This is sort of a weird size. It's I've mic'd both of them, and it measures 1.780. So that's what we're going to make it. Take a light cut across there and see how it does. So we got about 6 thousandths to bring it to size. Alright, this should be my finished cut, so I'm going to back out after this, after I clean the shoulder up. Alright, that leaves me 1 thousandths to polish this and bring it to size. I dialed in 5. I had 6 to come off, so it took off what I wanted there. I'm getting a little bit of taper, about a 1/2 thousandths there. So, alright, so we got this one where we want it here. Alright, getting ready to finish this one. This one finishes 0.999, so it's 1/1000th under 1 inch. I already got my shoulder length set on my 0 here. Alright, so what I'm going to do is just I'm going to take a cut here to 15 thousandths, and then we'll take a final cut. About the same thing. We've got about 6 thousandths to finish it. So I'm going to take 5, file it down. Alright, time to finish this journal here. This will be for the threads. That's going to finish at 3/4 or 0.745. Same thing, we're going to make one cut. We've got about 25 to come off. So I'm going to make one cut and then finish it. Right. 746, good to go. Okay, you've got an undercut from the end of the shaft down, and so the length of the threads themselves are a ½ inch. So I've got my zero set here on the shoulder, and what I'm going to do is back off a half inch. I'm going to go past it, say about 10 thousandths right there on the dial, and I'll reset a 0. And now I'm ready to make this undercut. Alright, so that should be the undercut. Let's see what I hit my mark at. 645. Okay, I'm just going to break some edges. I'm using a Style D brazed on tool. Okay, I'm getting ready to thread this here. Got my threading tool set up, and this is the part I wanted to show you. On a cross slide on this particular Monarch, and I know that many other Monarchs have this feature, you have a stop on this, so that once you engage it, this little button here, once you engage it right there, it'll come up to a stop point every time. So you know that you're coming right back to the same position every time. On some of the other lathes that I run, especially like my Victor and the Birmingham at work, doesn't have a spindle lock for the cross slide here. So you gotta, you bring it back to 0 and you gotta eyeball it every time. But this is a really nice feature because it comes back every time. And you just remove this button and you position the cross slide where you want it, whatever you're doing here. And then you bring it in, and usually you'll have like, one full rotation. It stops, and then you have to adjust your, you got to touch off with using your compound here. So, all right, so I've got it set. I've got my dial set on 0, and I'm going to use the compound, come in here and touch off, and we're going to cut a 16 pitch thread on this. And here's the nut. I ran a tap through it just to make sure it was good and clean. There wasn't no burrs or crud inside of it. And we're going to go ahead and cut a thread here. I haven't used this thread lever on the Monarch in a while, so it's kind of in a weird position to me. Okay, it looks like we're on 16. Around 45, 46 thousandths, as it says on the chart. Okay, got some people texting me there. Alright, this compound is the one where I got to go double of what it says on the chart here. Thought I'd give you a little clip of running the carriage here. This is the lever for the half nuts here. In all my other lathes, it's positioned over on this side where I push it down. And this one right here is to the left, so I'm having to like pull it over like this, and I don't use it that often, so it's a little weird after using all the other lathes all the time. But anyway, we got a little bit more to take off. So I don't even have to really look at this zero. I can just bring it back up till I feel it stop. Let's see if it fits. I'm getting real close now. Not quite. Need to take a little more. There it is. It's got a good feel to it too. I dialed in 90 thousandths. The chart says 47 thousandths. I had to double that. It doesn't have any rock, so we'll just have to polish those threads up a little, and that's good to go. Okay, moving on to the we're going to go ahead and machine the angles here, and I figured this one at 5 and this one here is 25, and I just used this angle gauge here. This was my granddad's, and he cut it off, and it's great for getting up real close. And nothing really critical on this. What I'm going to do is we'll scratch us a line here where the taper starts, and so I'll cut a 5-degree angle till it blends with the line, and then I'll turn the compound again and cut the 25 degree, which will be, you know, like from this corner here up. Alright, I got the compound set on 25. I'm not going to be able to do the 5-degree bevel right now because the compound's either going to be over here against the chuck or it's over here against the tailstock. So what I'm going to go ahead and cut this one, finish it, and then the last thing I'm going to do is I'm going to chuck it up closer and not worry about the center, and just go ahead and cut that last bit. That way I can swing the compound around back here and the tailstock won't be in the way. I went ahead and changed my insert to a larger radius so that I would have a radius right there in that corner too. Do is just try to touch off this journal and back it up to the shoulder. Alright. blended nice there. Just got to do some finish polishing on it. Alright, I'm going to go ahead and finish this last journal here. This is where it presses into the spindle housing. So I'm going to go ahead and set my stop. That's 2 3/16. And I want to get that turned and then let the shaft cool. And then I'll do all the final polishing on all the journals. Alright, we've got about 1/1000 to come off of it. Good on that journal. We got it a half under 1 inch, which is what the other good spindle might, and we're good to go. We got it polished up. I'm getting ready to move it back. I can still see my line scratched in there for this 5-degree angle we got to cut. I'm going to go ahead and use this blue Sharpie and make a brighter line that we can witness. Right there. All right, now we got room. Get in here and do a little work. Okay. Done got her trued up and ready to roll. Not bad. Okay, I think we're good. I just cut into my blue line, so I believe I'm going to leave her there. I'm going to hit it with a file and polish it just a little bit. Alright guys, well I believe we got all the lathe work done on this spindle. So, I believe next step is we're going to do some milling, drill a hole, and then we'll cut it off after that. It's not a lot of cutting that we got to do here, so I'm just doing it dry, using a 5/8 mil. All right, well, I'm ready to put this thing back together. Just wanted to point a couple things out before we do this. All right, I want to press it right here. This is your, your seal fit, and I found a piece of aluminum tubing that was the perfect size. I faced it and I had to cut a little bit of a chamfer on there to clear the radius here. So that's going to sit flat and give it a nice firm base in the press there. All right, the side that we're going in, I flapped this corner and made it nice and soft and round, and I went ahead and there was one little galled spot through here where it came out. So I hit it with a flapper and just really lightly just cleaned it up. So I'm going to go ahead and stick that in here in just a minute and tap it with a rawhide just to kind of get it started, and then I'm going to move everything to the press and we'll press it back in there. And the flats are oriented with this arm right here, so it's just an eyeball thing, and I'm just going to line it up and stick it in there. All right, guys, I got her bumped in there. Just started with the rawhide, got her centered up, and we're ready to press it. Okay, we're there. Home free. All right. All right, guys, well, we got the spindle finally finished up, machined a new shaft and got her pressed in there, and everything looks good. It's all on size. It pressed in nice and tight just like it was supposed to, and we're ready to roll. I'm ready to call the customer, tell him he can come and pick them up, give you a little bit better shot of it up close. And there's the washer and the nut. So everything fits good, and I just mirrored the the old shaft here. So that's it. We got this job done, and I enjoyed showing it to you. We had a few extra things in there that I haven't got to show before in some other videos, and hope you guys enjoyed watching. Thanks for everybody's support, all your great comments. I appreciate it. So all right, this was done. I gotta go find something else to get started on, so we'll see you guys later.